I'm presenting on a narrative case study of citizen science supported wearables for raising guide dogs. As Patrick said, my name is Timothy Holder, and I work in Dr. Alper Bozkurt's lab. So today I'll be discussing some of the critical needs in guide dog training, the design context and the design goals that we have, the actual systems that we developed, and then our beta testing process, following that up with troubleshooting and protocol updates, and finally what we're doing right now as we move towards large-scale deployment. So we kind of have four main project aims for the overall project that you should focus on as you watch this presentation. The first is designing with the animal and human users in mind, so focusing on their perspectives. The second is creating a complete integrated solution for our nonprofit partners. So it's end-to-end what they need for what they're asking us for. The third is employing citizen science. So this is where individuals who are non-research individuals collect the majority of the data. So if you've ever been a part of a bird watching project where citizens upload what they see and where they saw it to a unified database, this is kind of thing that we're trying to implement. And lastly, we're also trying to scale up to a large cohort, which is the bulk of the focus of this presentation. Who are we? We are an interdisciplinary team of electrical engineers, computer scientists, veterinary scientists. I'm a biomedical engineer. We have statisticians in the team. And so there's a lot of people working together to make this project possible. Okay, so just some general numbers about guide dog programs. They tend to cost about $50,000 to raise a guide dog from birth until partnering with their human partner. And then during this entire process, there's about a 40% attrition rate. So as I've been mentioning, our nonprofit partner is Guide and Eyes for the Blind, and they tend to graduate about 160 guide dog teams annually. They focus extensively on the data that they collect. And so this includes genetic information, behavioral information, and hopefully the solution that we're presenting will add to the streams of data that they use to get better results. To this end, here's an example timeline of the guide dog raising process. So on the top line, you have months and the costs and different periods of time where the costs are relevant. The blue triangles show different activities that are relevant to the dog, but the main thing you should pay attention to are the blue and red boxes, with the blue boxes indicating the puppy's experience and the red boxes indicating where the puppy is physically. And you'll notice that in the middle there, where I have the purple box, there's a 12 to 16 month period where the potential guide dog puppy is with a raiser family, a volunteer raiser family, and the GEB expert staff don't really have access to the dog during this time period. And this is a target time period for our study and for our solution. Okay. And there are lots of questions that GEB is interested in, but there are kind of three questions that are core. So the first is, what is happening during this black box time period? That's obviously a pretty important question. The second is, can we get objective data across raiser families? So scaling it up to some extent. And then the third question, core question, is how can we aggregate information across all of our data streams, so genetic, behavioral, and other data streams, in order to get earlier decisions made for the suitability of a puppy for a guide dog career. And in addition to these three core goals, there are some additional questions like, how does a puppy respond to stimuli in the natural environment? That definitely affects guide dog suitability. What is the frequency of raiser socialization sessions? Is there a certain optimal pattern for socialization? And things of that nature. So as a research team, as an interdisciplinary research group, we have several animal-inclusive design principles that we prefer to follow. And so I've listed only a few of them here. The first one I want to mention is invisibility, and this refers to seamlessly and ergonomically integrating our designs and our systems into the human and the puppy's extant routine, so what they're already doing. The second is focusing on the user perspective, as I mentioned earlier, and this includes largely using empathic walkthroughs to design our systems and the procedures that are involved in our protocols. Next, I want to talk about the cross interactions between our technology and the dog's natural environment. So this includes paying attention to things like curtains, carpets, grass. What is the dog going to interact with on its normal routine, and how does our technology interface with those things, either negatively or positively? And finally, we are very focused on creating a positive project experience for everyone involved. So not just have them collect data for us and to help GEB and us reach our research goals, but to also promote a better experience in their life and give them a positive experience in general. And so these inclusive design principles from our lab and GEB's research questions and goals dovetail into a process flow for how we designed the solution to their particular issues. And these declarative statements, I believe there's 6 of them, demonstrate kind of what we were focused on when we created our solution. So the first is that the solution needs to be versatile. It needs to be able to work for free-range puppies. It should be cost-effective, as I believe the previous presenter mentioned. There's not a lot of money that goes to these programs to some extent, and GB is a nonprofit, and so we need the solution to be able to scale up reasonably, but not cost too much. The solution should also be both intuitive and invisible, and I mentioned some things about that earlier in terms of how it interacts with the environment and how the human and puppy interact with the actual solution that you create. Of course, we want the solution to give us meaningful data, so data that GB can actually use to make the decisions that they need to make. And then finally, we want the project process to be smooth, a good experience for all the stakeholders involved, everyone from the raisers, the GB expert staff, even the engineers involved. We want all of this to run smoothly. And so the primary solution that we developed to address these challenges and to follow that criteria flow that I just mentioned is the smart collar system. And it's composed of a wearable hardware system, several software components, and also some study coordination infrastructure that lubricates the entire experience. So on the hardware side, the smart collar wearable device is deployed normally around dogs' necks. In size, it's about 48 by 43 by 12 millimeters. It tracks physical activity and location in concert with the smartphone application, which I'll mention in a second, but it also tracks several environmental factors that you see there listed on the left. The packaging is based off of the Roughwear Beacon, if you're familiar with that technology. And so it fits inside of that and is essentially splash proof, and puppy proof. We also designed the device to be cost effective, so under $100 per device, and it can be scaled up by a non-NCSU manufacturer quite well. So for more details about the hardware design specifically, I reference you to the Williams et al. 2020 paper that you'll see in my references later on. Okay. Yeah, so the software has several different components. There's an on-device firmware component that enables proper sensor operation and over-the-air updates that we can send to push to razors remotely. The wearable connects to a smartphone application via low-energy Bluetooth. And this smartphone application allows razors to see data streaming in real time, check how much data they've collected and uploaded, and it also allows them to annotate in real time activities that they're engaging in with their dog. So if they're outside on a socialization walk, they can actually note that, and then that will be sent to us and synchronized with the data that they're collecting. Then the smartphone app communicates with a cloud-based repository hosted by IBM, and that's done via Wi-Fi, and it can handle multiple data streams simultaneously. And one additional benefit of this cloud-based database is that it gives us access to IBM's powerful Watson analytics as well. So together, these software systems help us to hopefully deploy about 250 devices simultaneously and have about 1,000 razors asynchronously run through the entire program. For more details on the software design specifically, please reference the Cleghern et al. And the Malin et al. Papers that I've cited below. Okay, where am I? Okay, so the study infrastructure is my particular role in the project. So we need to make everything run smoothly to make the engineers happy, the stakeholders happy on the GB side and the razor side. And so essentially we divided participation by humans, by razors specifically, into 3 different epochs within the entire study. And there are several different tools that we use to, like I said, lubricate the experience throughout these 3 epochs. So for spanning across all 3 epochs, we have a centralized website that provides all the resources to a razor so they can go and peruse that site if they're interested in joining the study. If they have questions, there's a frequently asked questions section. All the downloadable materials are also found there. So that the website is a pretty key component to centralizing everything for the large scale study. We also developed a ticketing system, and the main feature of this system is that it has a uniform template for communicating between non-technical and technical staff, non-technical razors and technical staff. And so that's extremely useful for helping us to troubleshoot issues that razors come across. We also have a contact email where we can communicate directly with individual razors or with the entire group. So then moving on to content to onboarding, razor onboarding, we have consent forms that explain exactly what the expectations of the razor are for the project, what's going to happen to their dog in the project. any risks and benefits that accrue to them as being a part of the project. We also have both training videos and a physical training guide. And the goal there was to have a multimodal method of communicating with the raisers, how to use our technology and how to collect data in the study, so that any person with any type of education or learning preference can access the information. As far as study adherence is concerned, our primary mode of encouraging this and compliance is by using a package insert. So when you first get your device from our study, after you signed up, et cetera, you get the device, you get a charging wire, you also get this slip of paper that we call the package insert. On the front side, it directs you to the website and gives you lots of information about how to collect data properly. And on the back side, it actually has a bingo card where you can denote things like play with my dog for 7 days straight, or socialize, for 14 weeks or something like that. And the goal behind that bingo card is to encourage people to interact with their dog while also wearing the smart collar. And there's a slight reward, a small reward as a result for getting one of your bingo rows or columns or diagonals filled out. We also have a newsletter that provides general information about how the project is going, so updates along those lines, interviews with engineers or GV staff, and particularly awesome raisers get to be featured in this newsletter as well. So this is another element that we use to promote the study adherence. And finally, we have several different kinds of surveys that we ask them to complete during the raiser data collection. So in the second epoch, we ask them to do intermediate surveys roughly every 6 to 8 weeks, or at their personal discretion. And these surveys ask them questions about how is the dog doing so far? How is your interaction with the smart collar? What do you expect? Do you think your puppy is going to be a guide dog in the future? And then the exit survey asks them questions like, what was your experience with the project? Questions very similar to the intermediate survey, but also, would you recommend this to other people? And is there anything about the entire process, hardware, software, or infrastructure that you think we should change? And so, just to give a quick overview of what a typical human and dog would see participating in our study, the human would get a recruitment email, contact the study coordinator, they would get the raiser materials and consent forms, and then they receive their device, package, and insert, and complete their onboarding that way. And then during data collection, the human essentially, initially on the first day, I guess, sets up the smart collar and the raiser app. And then from every day on in the next 12 to 16 months, they just collect data daily, which involves pushing one button to turn on the collar and then opening the app and connecting the collar to that app. And then obviously completing intermediate surveys, as I mentioned earlier. From the dog's perspective, one thing that the raiser also does is complete an intermediate survey with their perspective in mind. So what is the dog seeing? What is the dog doing? How does the dog interact with the collar specifically? As much as they can, put themselves in the shoes of their dog. And then also the dog wears a device on their collar daily, and that's the extent of their data collection interaction. For offboarding, once again, they contact the study coordinator, and then they return the equipment to us, and so and complete the exit survey. So this is part of how we lubricate the citizen science process of remote data collection. Okay, so we completed 2 rounds beta testing. The first round was with about 15 GED raisers and staff and their dogs, and this lasted for about 6 months. And we primarily focused on evaluating the hardware and software systems for this round of beta testing. For the second round of beta testing, that lasted for about 10 months with 18 testers, and included an evaluation of our study coordination systems along with the hardware and software updates that we'd implemented. From these testing periods, essentially we were trying to see how the smart collar is deployed outside of the lab in unique physical spaces, in the unique physical spaces of raisers and the puppy's daily activities. We got lots of valuable information about various failure modes, which I'll talk about in a second. And then also we got some feedback on our designs from non-technical users. So something can look a certain way for us as engineers, but then out in the field is very different for people who actually need to use our technology. And then we also got some suggestions for new features, which we actually added and updated the system with. Okay, so as far as failure modes are concerned, the issues tended to fall into about 3 different categories. And then we labeled them based on the sub-team within our group that addressed them. So the first were mechanical related issues, tended to center around hardware problems, like, for example, switching from wireless charging to wired charging, which made the process easier for raisers. We also edited the circuit design somewhat to remove onboard obstructions that were affecting the Bluetooth range. So just addressing these kinds of individual problems is an example of the mechanical related issues that were brought up in the beta testing. We also addressed some app and database performance related issues. So, like, for example, some issues with spontaneous app disconnections from the smart collar, some spontaneous app crashes, and then also some issues with uploading to the database. So once again, these are just examples of some of the problems that we dealt with that were highlighted in the beta testing round. And then finally, the second round of beta testing identified several coordination issues. So things like the ticketing system not working as it should, or the instructions not being as clear as they could be. And so we also dealt with some of those user interface related issues. So real life testing, the beta testing that I mentioned earlier, also inspired some project level, like not sub team specific changes. And one of the main changes was implementing a standardized in-lab testing protocol that is done internal to the research team, so within our research group. This protocol evaluated things like connection range, reconnection characteristics, how the device functions when the iOS device with the smartphone app is in normal usage, how does it work when there are multiple Bluetooth devices connected to it, so like headphones, smartwatch, how does it work when there's multiple apps running in the background or foreground, these kinds of things. However, our primary focus was to evaluate each sensor and make sure that it was working properly. So there we go. So yeah, here's an example of the data output from our sensor tests that we were checking. And so in the top left box A, you can see that we tested our sound sensor by playing one sound, five different volumes. And that sound contained puppy barking, an adult dog barking, and a human talking. And you can see that our sensor is working well there. Testing of the activity level sensor was essentially just moving the smart collar around the 3 dimensions of motion. And then for light sensor testing, we did covering the device and uncovering the device. And then for all of the additional environmental sensors, we compared the outputs and readings to a NIST certified weather station. Okay, awesome. We also pared down this full standard in-house testing, which we call SIT, to a standard at-home testing protocol, which we call SAT. And this can be run by Razors at their home location in less than 15 minutes. And so the reason why we did this is so if a Razor contacts us through the ticketing system with a non-trivial issue, we'd ask them to run SAT, and then the quick sensor checks and playing the exact same sound file that we use and completing some of the additional tests that we did allows us to compare the functionality in the field of our system with what we tested the system to do in lab before we sent it out to everyone else. And this strategy has been extremely useful and extremely helpful in allowing our team to pinpoint the locus of issues within our systems. So it could be a hardware issue, a software issue, or well, usually it's not a study coordination issue for this particular thing, but it helps us pinpoint those issues much better. Okay. And in addition to the SIT and SAT protocols, another project level change that we made was instituting a data pre-checking step in our data management pipeline. So here you can see an example of a significant gap in some IME data that was collected. And to help us catch issues like this, we created a software module that provides some simple statistics like means and quartiles. And then it also checks for irregular data points or patterns. So it looks to see if there are spans of missing data or double lines of data or a naturally high or low values. And doing all those different types of checks, it produces unique identifiers, which you can see in the props column, so that we can track issues. So an example issue could be barometric pressure is too low and beyond the realistic range, or we missed data points during upload or storage. So rather than waiting for Razors to catch all the issues on their end, this step allows us to preempt certain issues, and then we can reach out to ensure that high quality data is collected throughout the process. Okay, so we've discussed some of the ideation and initial design components of the system that we've created to help GEB get into that black box. We've talked about some of the hardware, some of the software, some of the study coordination. You can definitely ask questions about those things, because this is a very broad review. But currently, we are making some final updates to our smartphone app. We also just received a large shipment of devices from our manufacturer, and we're going to be working with those. And so the next step is to complete Razor recruitment, onboard a large cohort of Razors to work with this study, and then to actually do the official data collection and analysis. So that's where things stand there. And if you remember from the beginning of the slide, or beginning of the presentation, we have several project games, employing user-centered design, creating an integrated solution, incorporating citizen science, with one of the main ones being scaling up to a large cohort and helping the field think about these kinds of issues. So I've prepared a few main takeaways for stakeholders in this process who may be interested in doing some of the scaling up. So a full list is in the paper, but for hardware, it's very important to walk through the Razor puppy's experience to know how your hardware is interacting with the environment that the puppy is going to interact with. We highly recommend having a backup for the data process. So on our system, we have an SD card that if the connection is lost between the smart collar device and the software app, the data can be rerouted to that storage place. We highly recommend obviously doing multiple rounds of beta testing and addressing the issues as they come up, but discussing with your beta testers what they should be looking for beforehand is a highly recommended step that we implemented in the second round. And then when you get a set of devices from your manufacturer, you should definitely evaluate each of them before you send them out. That's a pretty important step as well. On the software side, we wirelessly transmit our data, and that's a consideration that people can make. It does make the puppy's interaction with the real world a little bit easier. Using smartphones to enable GPS location is another feature that's helpful for certain types of tracking and knowing how far they're going on walks when they do go on walks. We highly recommend including a data pre-check, and then also having a centralized location rather than trying to manage everything by emails. Once you scale up to a large number of subjects, you definitely want to have more automated processes in that end. As far as the coordination side is concerned, content documents should definitely clearly explain the project and explain all types of risks. So some people have some concerns about electronics, for example. You should clarify exactly what power levels that your device uses and what the risk of shock is and that kind of stuff. I highly recommend creating multimodal training materials. I'm a reader, I prefer to read, but some people prefer to watch videos. So that's very useful if you're addressing a large population. Actively thinking about study adherence is another recommendation that I'd make, or that we would make. So employing incentive systems, newsletters, surveys, and other tools. And then having a uniform troubleshooting methodology really helps when you have over 250 people, not all of them, but like a large portion of them sending in different concerns or questions. You definitely want to have a unified way of not missing any of those. And then finally, we highly recommend that you always have an interdisciplinary team, if not working on the project, but also as consulting with you. And so if you don't take away anything else from this presentation, what I'd like you to remember is that you should always have an iterative design. So you put something out there, you test it, you get feedback from all of your stakeholders, and then you go back into the lab, I guess, and recreate. And then also have a very inclusive design where you focus on the perspective of every single stakeholder. So what are the engineers seeing? What are the GP expert staff seeing? What are the actual razors seeing? What is the dog seeing? And this will help increase your chances of success and certainly increase the satisfaction of all the stakeholders involved in your project. With that being said, I'd like to acknowledge support from these grants from the National Science Foundation and also IBM Faculty Awards for supporting these projects. Very special thanks to the GEB members for providing their expertise and all the razors and staff that helped us do this project. And I'd also like to thank my fellow members of the iBionics Lab under Dr. Alper Bozkurt and the Cleghern Lab under Dr. David Roberts. With that, these are the references for the presentation. And I'm happy to take your questions.